Hello, this is 5.7. In this lesson, we're going to prove triangles similar by SSS and SAS. And this is actually the end of our shortcuts for similarity. So once we're done with this one, we're in the clear with that. So first one is SSS, stands for side, 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 just like it did with congruency. So that's kind of nice. The difference is in similarity, we're not looking for congruent sides, we're looking for proportionate sides. So if all three sides of one triangle are proportionate to all three sides of another, then they are similar. So the diagram here, I think, does a decent job of explaining what's going on here. So the triangle on the left has sides of 2, 3, and 4, and the triangle on the right has sides of 1, 1.5, and 2. So I tried to pick just easy numbers that you could see and just kind of see what's going on here. So because 1 divided by 2 is the same as 1.5 divided by 3, which is the same as 2 divided by 4. Those are all congruent to a half, right? The bottom numbers are exactly twice as big as the top numbers. Because that's true, those guys would be similar by side, side, side. The second one we're going to talk about today is SAS, which stands for side angle side. And again, very similar to what it was with congruency, except we're not looking for the sides to be congruent. We're looking for them to be proportionate. So basically the scale factor between them to be the same. But we are still looking for that included angle, the angle between the sides, to be congruent. If that's the case, then your triangles are similar. So I kind of picked the exact same triangles here. Except this time I just gave 2 sides and that included angle. So you'll notice that each of those triangles has a 100-degree angle, and then we have proportionate sides. So you would do side, angle, side, side, angle, side. And on a problem like this, you would want to show your work and show that those sides are in fact proportionate. So you'd maybe want to check your short sides. You have 1/2, and then you'd maybe want to check your other sides, your longer sides. So 1.5 divided by 3. And I know I didn't talk about that much on that last example, but one thing you can do on ones like this where you have those weird decimals is you can actually start by multiplying by 2 to get rid of your decimals. So 1.5 times 2 is 3, and 3 times 2 is 6. And now you can divide by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So since your sides are proportionate, and since that angle in between is congruent on each triangle, then by side, angle, side, they are similar. All right, so we have 3 examples here. First one looks like this. Take a second to make sure that that's in your notes. And then what we're going to do is very similar to what we did with our congruent triangles that look like this. Is we're going to mark anything that's extra. So anything that's not already marked that we know is maybe congruent, we should mark. So right there, we have vertical angles. So a reason why we can add those extra marks, vertical angles are congruent. All right, so now I'm thinking that they might be similar by side, angle, side. So we can see we have a side given here, we have an angle and a side, and then over here we have a side and an angle and a side. Okay, so to be sure we have the angles congruent already, we need to check to make sure the sides are proportionate. So I'm going to start by matching up the short sides. So the short side on what I will make the red triangle is 9, and the short side on what I'll make the green triangle is 15, right? Those are the small sides. So I'm going to do, I'll go right to left, 15 divided by 9. Okay, each of those are divisible by 3. So 15 divided by 3 is 5, and 9 divided by 3 is 3. So scale factor is looking like it might be 5/3. We need to check it for our remaining sides. So 30 and 18. And since I did right to left before, I'm going to do right to left again. So 30 divided by 18. And each of those, I believe, are divisible by 6. 30 divided by 6 is 5. 18 divided by 6 is 3. So we got 5/3 and 5/3, and we have those congruent angles. So yes, These triangles are similar by side angle side. Scale factor, or K equals 5/3. And then similarity statement, I'm going to go triangle ACB is similar to triangle. Let's make sure we go in the same order. So I went long into that angle and short. So I want to go DCE. Like so. All right, example 2. This time we have a whole bunch of sides, so I'm thinking that they might be similar by side, side, side. I do notice that there's really nothing else extra that we can add, so we should just go ahead and start checking sides. So I'm going to do short and middle and long. So I'm going to find the shortest side. So 8 is the shortest, and 84 is definitely not the shortest. 48. So 8 divided by 48. And I'm just going to wait a minute to reduce those. I'm just going to get them all set up first. So 8 and 48. Middle looks like we have 12 and 72. And then our long ones, we have 14 and 84. All right, so if those numbers are kind of big like they are there, I would suggest either you can use a calculator, that's fine, or just kind of use what you know to begin with. Like, I don't exactly know what goes into 8 and 48. I mean, I do, but if I didn't, maybe just start by cutting them in half. So maybe go to like 4/24, and then maybe cut it in half again. So 2 and 12, and then cut it in half again, 1 and 6. Okay, if you happen to notice right away that you could divide them both by 8, that's fine. But if not, just keep kind of cutting them in half. Okay, I'm going to do kind of the same strategy for 12 and 72. So 12 divided by 2 is 6. 72 divided by 2 is 36. I'm maybe going to cut those in half again. So I'd get 3 and 18. And then those guys are both divisible by 3. So 1/6. And then last one, 14 and 84. If I cut them in half, I get 7 and 42. And then I know that 7 and 42 are both divisible by 7. So divide by 7 and we get 1/6. So there we go. 1/6, 1/6, 1/6. So are they similar? Yes, by side, side, side. All three of our sides are proportionate. So our similarity statement, I'm going to go, let's see, I'm just going to go ABC, keep it in alphabetical order. Why not? Similar to, so what did I do? I went green, blue, red. So I got to go green, blue, red. Green, blue, red. So HGF. All right, last example here. This one is a little bit trickier, so just make sure you pay attention here. Reason for extra marks is where we're going to start. So before we even do that, I'm going to make it a little more obvious what we're looking at here. We have a red triangle, and what I'm going to make a blue triangle. Okay, so reason for extra marks, what I noticed right away are those two triangles both go through point K. They both share angle K. So we can mark that as congruent on both triangles. So they share angle K. Okay, are they similar? Maybe. Reason here, if they are similar, would probably be side angle side, since we don't have all three sides, but we do have that angle in between two sides. So let's check. I'm going to pick out the short sides of each, and I'm going to pick out the long sides of each. So starting with that red triangle, we have 16 and 32. 16 is the shorter side. And the shorter side of the blue triangle is this 88. So 16 and 88. And then for the long sides, 32 over. Now on this blue triangle, we don't have the whole side given to us just yet. We need to add together 32 and 144. So 32 plus 144 is going to give us, what, 176? So if you want to kind of add that to your diagram, that whole distance is 176. So that's our blue long side. Okay. Now those numbers are pretty big. Totally possible to do them by hand, but on one like this, if you just want to grab a calculator and type them in, you can do that. So I already did them. I got 16 over 88 is 0.181818, and 32 over 176 is 0.181818. And also what you can do is you can click this fraction key on Desmos. That's kind of nice, and it will give you the reduced fraction form. So 2/11ths for each of those. All right, so are they similar? Yes. Reason being, side angle side, we have proportionate sides and a congruent angle in between. Scale factor, as long as we're at it, would be 2/11ths. And then similarity statement, I will go little triangle first. So I'll go triangle BKC is similar to triangle LKM. And that is it for that one. Sorry for the long video. Try to stay under 10 minutes, but didn't quite do it on this one. So at this point, you can go ahead and practice 5.7. Let me know if you have any questions.